In this lesson, we're going to install the user-defined function block that is going to allow our Micro850E to control this linear actuator. That's going to turn it into a really economical motion controller. We're going to start in Connected Components Workbench with a new project, and I'm just going to call this my LMC application and create. And then we're going to go to Controllers, Micro850, and we want the L50E. Any of these will work with this linear actuator. And our trainer comes with a 2080 L50E 24 QBB. We're going to select and add to project. And the first thing we need to do is go to YRG's website and download the user-defined function block. We're going to start at yrginc.com. And you'll want to log in. And once you log in, you'll have access to their software page. Now, it doesn't cost anything to create an account. And to save time, I've gone ahead and downloaded the user-defined function block. To bring it into Connected Components Workbench, we're going to right-click the Micro850 at the top of the left pane, import, and import Exchange file. Then go ahead and browse and find your file, select it, and import. Now let's add a program to put it in. So we're going to right-click Programs, add ladder diagram, and open up that program. And then on the user-defined category, we're going to bring down the TS single. Now by default, this column width is way too narrow. You see how it's truncating so much of this text? So what we need to do is edit the properties of the ladder container. Now this can be difficult to find. In fact, let me close this up. Because even if I right click here and go to properties, see, I don't get what I need. What I've found is you can always right click to the right of the ladder here and go to properties here. And then I'll open up this ladder container. And then let's change our cell width. Let's make it 50. That way we can see everything. That gets it where it spells it out nicely. At the top of the user-defined function block, the first thing it's asking for is the map robot outputs and map robot inputs. We need to add them to our Ethernet configuration. So in Studio 5000, this would be where we go to I/O configuration and add it as a generic module. And in Connected Components Workbench with the L50E, we can do that. But to get there, we're going to double click on the Micro850 at the top. And first, let's click on Ethernet, because every time we create a new program, we also have to set the PLC's IP address in it. And I'm going to make this 192.168.1.10, which is our default trainer IP, and a subnet of 255.255.255.0. Then let's go to modules inside of Ethernet, and we're going to add. And I'm going to call this the LMC. And my IP address is going to be 192.168.1.13, which is the default IP address of the linear actuator on our trainer. Then we want to set our RPI to 10. And for our COM format, we want an int. Then for an input assembly instance, we're going to be at 100 with a size of 6. Our output is going to be 150 with a size of 6. And our configuration is going to be 1 with a size of 0. We're going to click OK. Now we can go back to our program and we can select our dropdown and start typing LMC. And there's LMCI and then LMC, and that's going to be LMCO. And for the rest of these, we're going to create tags for each one of these. Now, if you click on the top part, you're going to get a dropdown. But if we click on the bottom part, notice it just highlights it. So if you'll double click then, it'll bring up a variable to go ahead and create one. So this is going to be the serial number. And we're just going to go through these and I'm going to type exactly what it was saying there. EN phaser. When you're finished, yours should look like this, and this is actually enough to operate this linear actuator, but I want to add some more code so that we can operate it from the switches and get a little bit of indication on what's going on. In fact, we need to go ahead and put some descriptions on our I/O. So let's open up our global variables on the left pane, and output 0 is our green light. Output 1 is our yellow light. Output 2 is our red light. And if you're wondering, all these are coming from our Wiring Enough to Get Started guide. Input 4 is going to be our green button. Input 5 is going to be our yellow button. Input 6 is going to be our red button. Input 7 is going to be our blue button. Input 8 is switch 1. And that's all the getting started wiring. And then in the previous video, we gave some additional wiring for this one. That'll be switch 2 for input 9. And then input 10 will be switch 3 left. Input 11 will be switch 3 right. Input 12 will be switch 4 left. And input 13 will be switch 4 right. And then actually, while we're here, we're going to make switch 4 our HOA or handoff auto. So this is going to be switch 4 left hand. And this will be switch 4 right auto. And they're going to use switch 3 to be able to jog the actuator. So switch 3 left will be jog forward. And switch 3 right will be jog reverse. And let's go over to our program and bring a new rung in. We're going to bring a go look for 1 direct contact down. And we're going to know that we're in hand. So that's going to be switch 4 to the left. And if we're in hand, we're going to let it jog. So we're going to bring another go look for 1 down. And this will be switch 3 left. And that is going to do a direct coil or output energize to jog forward. All right, and we almost want the exact same code to jog reverse. So we're going to right click and copy that rung, and we're going to right click and paste that rung. And here we're going to go grab input 11. And over here, we're going to go grab jog reverse. Now, before we can actually jog, our servo needs to be on. So we're going to bring another rung down. And we're going to go look for a 1. And actually, we want our servo to be on if we're in auto or we're in hand. So we're going to go find switch 4 again to the left. And we're going to put a branch around that one. And we're going to go look for a 1 into that lower branch. And this will be switch 4 to the right. And when either of those conditions are true, we're going to turn our servo on. Now let's bring another rung down, and this will be for our auto mode. So whenever switch 4 is to the right, we want to be in auto. So I'm just going to right click this instruction and we're going to copy it. We're going to right click right here and we're going to paste. And then we'll bring an output energize down and we are going to go find auto mode. Now, if we're in auto mode, we need to tell it where to go and what speed to go at. We're going to use the absolute positions on this one. So bring another rung down. And in this case, I'm going to just put a move instruction in, and we're going to move the absolute position to the absolute position. So all I'm doing here actually is making this where we have a convenient place to look at it. And we're going to do the same thing with the speed. Bring a new rung down, bring a block down, and this will be a move. And we are going to move the speed to the speed. And one final one we're going to need is the interlock. And in this case, we're going to have the interlock be a 1 unconditionally. So we're just going to put interlock in. Not quite it. I just realized I forgot 2 rungs. So we need 2 more rungs. And in the first one, we're going to bring a move instruction in. And we're going to move a value of 1 to the mode select. And then when our servo is okay, that's when we want to say it's okay to move. So we're going to bring a go look for a 1 down, and we're going to find servo okay. And then we're going to bring an output energize direct coil down, and we're going to go to move okay. And that'll be enough to get us started with this actuator. So let's go ahead and download this program. And if you need any help downloading your program or setting up your communications, we have lessons on all that. Just go to the PLC trainers link in the description. Now, if you're like me, you get really excited and you're like, all right, let's switch 4 to hand, and we want to see it jog. And it doesn't work. And YRG has done an excellent job of giving you diagnostic codes. And error 20485, which is a hex code of 5005, means an invalid serial number. And what that means is we created this tag here for the serial number, but I didn't actually enter it in. So we're just going to double click on it. And the serial number can be found on the front of the drive. And all we're going to do is enter YRG and then that number. And now if we switch 4 to the left to put it in hand, we can switch 3 to the left and it goes up, and we switch 3 to the right and it goes down. Now let's try it in auto mode. And here's why we put these moves in, just to make this really easy. So we're gonna make our speed 50, and then let's make our position 100. And then I'm gonna switch 4 to the right, and it doesn't move. And notice we still have our error code in there. So we need to reset this, and we can do that with the reset right here. All I'm gonna do is right click it, toggle, and right click, toggle again. And this time we switch 4 off and back to the right, and it doesn't move. And the reason for that is, if you recall when you were setting this up, you had to plug the battery in. So this servo does not know where it's at right now. It's gonna let you put it into hand and jog forward, jog reverse. But if we want to actually do position control, then we're gonna have to home it. So I'm gonna switch 4 to the right to put it in auto mode. And then we're gonna right click the origin and toggle it. Then it'll go down and it's gonna home at one end of the actuator. Now, if we switch 4 to the center and then switch it back to the right, it moves up to 100 millimeter. And if we open up our move absolute position and we change it to 200, then when we press the enter key, it moves to 200 millimeter. Now we're ready to program a motion control application. But first, let's brush up on different ways that we can sequence through machine steps. Click here to follow me over there.